This section covers Finm C. In this video we're looking at compound interest. Now, unlike simple interest that has the same interest every single year, with compound interest, the interest earned by an invested amount of money or the principal is reinvested, so it too earns interest. So you're earning interest on your interest. Now, similarly, interest due on a debt at the end of a period is also subject to interest in the next period. The accumulated amount or the compound amount S has the same meaning as future value. So let's look at our formulas here for calculating compound interest. Firstly, our future amount equals our principal times 1 plus our interest rate, all to the power of n. Now, the things to note with this is that our interest rate is per period. And if you look down to the bottom here, you'll see that it's actually the interest rate per year divided by the number of periods or the number of payments. Okay, the number of times in a year that you're earning that interest or gaining interest. Similarly, n is the number of periods. So if you've got interest per quarter, okay, so if your interest is per quarter, your interest rate has to be divided by 4, and your number of periods are going to be times by 4. If you've got 4 periods, 4 times that you're getting that interest per year, but your interest rate needs to be divided by 4. Okay, also with this formula, you're ending up with your overall amount. So to work out interest, you need to subtract it. What you're ending up with, you need to subtract your principal away from that. Okay? So let's look at an example. Clarissa invests $5,000 at 6.2% with interest compounded monthly. That's the key. We really need to take account of that. What would her investment be worth after 5 years? Also, what interest would be earned in that 5 years? So let's write out our information. Our principal is $5,000. Our interest is going to be our 6.2% divided by 4 because it's monthly. Okay, sorry, compounded monthly divided by 12. I had that quarterly question in my head. Now, if you do 6.2 divided by 12 and you calculate, you're end up with a really yucky number. So what we're going to do is we're going to leave it as 0.062 over 12. So we don't want to keep approximating our answers. And our n is going to be our number of years times 12 because that's how many times we're getting interest per year. So that's 60. So S equals P 1 plus I to the n. So that's 5,000, 1 plus 0.062 over 12, all to the power of 60. Now when plugging in this in your calculator, remember those brackets. Remember to use the brackets on your calculator. You'll end up getting approximately $6,811.69. So therefore, investment would be worth approximately $6,811.69. For the second half of the question, our interest is going to be what we ended up with minus what we started with. So that ends up giving me $1,811.69. Again, finish with a therefore statement. Therefore, interest earned was, again, it's approximate because our first answer was approximate, $1,811.69. Next, it's possible to calculate the principal if the period of the investment and the compounded amount are known. And we do that by transposing the compound interest formula. And you can see this is my compound interest formula here. If I want that P on its own, I just divide by what's in the bracket. So I end up with that formula there. In a similar way, the periodic interest rate can be determined by transposing the compound interest formula. And you can see that there. That one's probably a little bit more difficult to see how they get that. So if we've got S equals P 1 plus I to the n, okay, I want to get that I on its own. So I firstly divide by P, and I end up with that. To get rid of that n, I do the nth root, up both sides, or put as a power of 1 over n, same thing. We end up with that. To get I on its own, I just subtract that 1 from both sides. Okay? So let's look at an example. What principal should be invested? So P, I don't know. So that it will compound to $13,000. So S will be $13,000 in 5 years' time at 12% per annum, and my key here is compounded quarterly. Okay, so that means that my I is going to be 12 divided by 4, which is 3%, or as a decimal 0.03, and my N is going to be 5 times 4, which is 20. So I write out my formula, which is S equals P bracket 1 plus I to the power of N. So I don't want that formula, I want my P on its own, so I'm going to bring the P out the front, divide both sides by what's in the bracket, I end up with S over 1 plus I to the N. Plug in what I have, so it's 13,000 over 1 plus 0.03 all to the power of 20. Go to your calculator and that'll give you approximately $7,197.78. So therefore principal required is $7,197.78 approximately. Now you don't have to rearrange your formula first. If I went from this formula, I could have plugged everything in and had 13,000 equals P bracket 1 plus 0.03 to the power of 20, and then I could have divided both sides. So instead of thinking about rearranging, I can do it after plugging in, and I still end up with the same answer. Next, what annual interest rate, compounded quarterly, so there's our key, would be required if an initial investment of $3,000 is to amount to $3,500 after 5 years. So we have principal is $3,000, our end amount is $3,500, my N is going to be 5 times 4, which is 20. My interest rate I don't know. Okay, I know though that whatever it is, it's going to, well normally, if we think about it, our I is going to be our interest rate divided by a number of periods, isn't it? So we have to remember that our R is going to be whatever our interest rate ends up times by N. So we're going to have to remember that at the end. Now we can use the rearrange formula which I showed you earlier, which is just that there, and we get the nth root of 3,500 over 3,000 minus 1, and it's the 20th root because that's what n is. Now note on your calculator you can do the 20th root, or you can plug it in as 3,500 over 3,000 to the power of 1 over 20 minus 1. And you'll end up with approximately 0.00774. Now I need to times it by, times it by 4 because of what we've had here. R is going to be I times 4. So I need to times that by 4. And that gives me approximately 0.0309, which I then times by 100 to get my interest rate of approximately 3.09%. Okay, you then have to finish with a therefore statement. I've kind of run out of room. You can see from the textbook the periodic rate of 0.7774%, so the annual rate would be 3.096 or 3.09%. Now note in the textbook they've got that 3.096. That's because they have used a rounded amount to find the percentages, whereas I've used my exact amount from my calculator each time. What now? Financial Management C1 exercise from the textbook. Remembering that your compounding period is really important to your calculations.